We're going to begin with a basic lesson on alcohol or alcohols in organic chemistry. Alcohols are defined as a hydrocarbon which has an OH functional group attached to the main hydrocarbon chain. This group is called hydroxy. If we start with a parent molecule called methane, methane is only one carbon, but when we substitute one of those hydrogens for the OH, we transform it into an alcohol. We take the base name of the molecule methane, we take off the E, and the hydroxy functional group is represented by the ending OL, thus giving us the name methanol. Let's try another example. Let's say we have the basic molecule ethene. We have two carbons, each with their hydrogens attached to it, and then we replace one of those hydrogens for an OH group. The parent molecule is still ethane, but now instead of leaving it at ethane, we cut out the E again, we add OL, and the new resulting alcohol is ethanol, which is also the alcohol found in regular alcoholic drinks that we consume every day. Let's talk a little bit about classification of alcohols. Alcohols can be classified according to their position, or the position of the functional group, or the amount of functional groups present. Let's make some examples. Here I'm drawing propane. I'm going to draw it repeatedly a couple of times, and then I'm going to add some hydroxy groups to it. First of all, depending on the position of the hydroxy group, the alcohol can be primary if the hydroxy group is attached to a primary carbon. Now, if this same hydroxy functional group is attached to a secondary carbon, this is a secondary alcohol. This is going to be relevant when we study reactions. How about if we have another hydroxy group, but this time it's attached to a tertiary carbon? Thus, we get another classification: primary alcohol, secondary alcohol, or tertiary alcohol. Now let's talk about the amount of hydroxy functional groups present in each of the parent alkane chains. Here we have one, here we have two, and here we have three. So, thus this becomes a monoalcohol. This will be a dialcohol. And this will be a trialcohol, and so forth, depending on the amount of hydroxy groups present in each of these molecules. Now, let's start with some naming. We're going to start naming UPAC style. So whenever we have more isomers, remember isomers can be structural or they can be positional. So let's say we have this same molecule. This is called butane. It's a straight chain, right? So what happens when we attach OH here or hydroxy here? We have the same basic chain, which is 1, 2, 3, 4 carbons. And here we have 1, 2, 3, 4 carbons. Remember, the hydroxy or the functional group is the star of the show. So it must get the lowest number possible wherever it's located on the chain. However, these are positional isomers. This means that the hydroxy group is attached at a different position on the chain. However, the molecular formula is going to be the same. So we could name this butane, but since it has a hydroxy group, we cut it out and we substitute it for butanol. Depending on the textbook you're using or consulting or your teacher, this could be 1 butanol, or it could just be plain butanol. Why? Because sometimes, since this is number 1, it would be obvious that the hydroxy group is at number 1. However, for this shape, where is our hydroxy located? It's clearly located at number 2. So we would write 2-butanol. Another variation of this would be butan, indicating that it's a 4-carbon chain with only single bonds, a dash with a 2 indicating the position of the functional group, which is ol. butanol. So either of the answers indicating the position of the functional group with the carbon chain for carbons are correct answers, depending on what your teacher is asking you.